been? Not convinced at all. How been? Hey! Nice. I'm so happy to be here. It's I feel a bit of an imposter being on a Java conference, but I'm here just to make some jokes with them, right? So today I'm gonna talk to you about some crazy experiments, and probably the last thing you're gonna think about this talk is like, why? So I just started creating Node.js from scratch. I started learning how everything goes. So today I'm going to show you the step-by-step and some highlights for you to understand how it's gone behind the scenes. Well, before we go on, please take as many pictures as you can. Mention me, mention the event, because this is how you can help spreading the word about this event. And actually, I can show good pictures to my mom, OK? Well, I have here also all the links. I have exclusive tutorial for you to follow along. So don't only listen to me talking at this conference. I know that's a bunch of content here. I know it's hard to observe, but you can try at home with a crazy step-by-step. Well, I'm going to start talking how I gathered or how I did everything here. First of all, I started working, trying finding something to work on Node.js. I was creating classes back home. And I found a bug in the Node.js core. And I was like, oh my god, I can try helping the Node.js. So I fixed this bug, and then I started trying being more part of the Node.js and much more. So this is how they nominated me to the Node.js core, and now I'm part of the Node.js team. Well, this was good, but at the same time I thought, oh my god, I'm not sure if I know enough to be a Node.js core team developer, right? It's like a very big responsibility. So I started asking myself, do I really know Node.js? Do I really know how Node.js is made behind the scenes? Do I know why is it powerful or not? Well, I figured that a lot of stuff, how Node.js was working behind the scenes, I was a bit confused. And I started researching and researching. I got to the Node.js website. And then I started recreating tutorials following the same idea. That all the time I had some questions, I started asking myself, well, why everyone is using socket.io in Node.js to create WebSockets? So I tried re-implementing the WebSocket protocol to get to know how this was done behind the scenes. I did the same for creating a code coverage tool, and I'm asking a bunch of steps. So being a curious person, it's nice because you are the first one, but being the first one, you struggle a lot, and it's very, very hard to make. As I told you, I was searching a bit about this thing, and I realized no one has ever done this before. If you search on Google, if you try finding repositories, even the Node.js core developers, even Google developers, they have no idea how to do this from scratch. So I found an opportunity, and I started wondering, OK, first of all, I'm going to try understanding how is the concepts, how V8, Libuv, C++, how they work together. So I went to the Node.js website, and I got some ideas, very, I would say, abstracted. So I couldn't see how it was working in practice. I saw a bunch of diagrams, but how it was working actually behind the scenes, I couldn't see anything. So all this talk is like highlights from my tutorial. I'm going to show the last video in the end for you. But yeah, go there, try this step by step, because this was a lot of effort. I've spent at least a month trying to do this. I almost gave up so many times, but I'm happy now to share that's going to work. Well, before we move on, I just want to say a bunch of stuff, right? First, I'm not a C++ developer. Probably you're going to see a bunch of bad practices and a lot of crazy stuff on the C++ side, but it was just me trying to make it work, OK? Same for you, who's not a C++ developer. Don't take too serious the C++ part. We're going to just see the arguments, the function calls, and so on, so we can understand the theory and how it's gone in practice. And all of this, as I told you, well, I started researching. I couldn't find any answer. So This is all part of my own research. This is probably, I gave this talk in Berlin, and Ryan Dahl, the Node.js creator, was there, and I was shaking. I was like, oh my God, I'm not sure if this is 100% sure, because it was me researching about his life and how he was making Node.js. And the last thing I would say, I'll always give some shout out to these JS runtime authors like Node.js, Deno, Cloudflare workers, because you're going to see how amazing, even for Java, right? How those people are abstracting these things so we can use an abstract layer, we can use a simple and accessible programming language to do powerful applications. So this is really nice. So we are here to talk about Node.js. Has anyone seen this website before? Nice. Oh, 4 people in the whole audience. This is amazing. This was Node.js in 2009. It was the first version. And you're going to see here, they use puts. They don't use console.log. So it was based, I think, on Ruby back then. But this was the first version. So I thought, well, it's better for me to go to the GitHub repo and try understanding how Ryan Dahl was doing all the first commits, how he implemented the first things. But before we move on, I would get you to 2009 and try understanding how the world was in 2009. Because I don't know about you, back then we had a lot of cool technologies, right? But how Node.js became so hype? Why people were using so much? So these were a bunch of questions I was doing myself. So back then, do you think all those platforms weren't working? Like we had no platforms? No, actually we had a bunch of technologies. We always had Java. We had Java serverless, P2P. We had S.NET Framework, C#, where I started, Python, and a bunch of other technologies, Ruby, Scala, and so on. So it is pretty interesting to see how Node.js became so popular. Well, to understand why Node.js was good back then, we should understand why was the problem back then, right? So I start to wonder, OK, why should someone move from Java in 2009? OK, I'm not talking about today, the present. I'm talking about that era. And I got some interesting things. The first thing for me, I started working with C#, and I had to learn C#, SQL. I had to learn jQuery, JavaScript in the back and the front end. I had to understand the ASP.NET Framework. So I had a lot of technologies. And for me, one of the best things and why JavaScript and Node.js was very popular back then is because you can use a single programming language to conquer them all, right? You can try using the same programming language to deliver something. Well, nowadays we see, oh, this is not a big deal, right? But when you're starting programming, this is something that you're going to think about a lot of things. Well, my opinion is that Node.js came with a very clever execution module. The way Node.js was made was to support real-time users and thousands of concurrent users using just a few resources, right? Let's get started with how the common execution modules were there. So you had your server, right? Your data centers happening all day there. And we had users. So every time I had a request, we had a resource group. I had a friend, I have some RAM, and some resources allocated for each individual request. What happens when I need to scale, right? A bunch of users trying to connect it. I will have a lot of memory allocated for those users, and I will need to scale my server because there's no memory or resources left, right? So the number of people or the number of requests I would support was proportionally related to the resources. And I would say this module, the blocking I/O, right? I had to wait for one user to free the main thread, or I had to schedule threads. This is very heavy, and this spends a lot of memory. So this was the problem from C#, from Java, P2P, Python, and most of the languages back then. And I don't know if you've worked with threading, but you have to you have to manage the threads. You have to avoid the thread lock when two processes are trying to change the single address in memory. So this was pretty hard to manage. We had, my God, so many complex semaphores and a lot of cool understanding about threading, right? Operating systems. So Node.js. Node.js, we had the same idea. We can support a bunch of a bunch of customers accessing the same time, but it's a bit different. See, in Node.js, we will have our server, right, as we were doing there. But the first thing is we have asynchronous I/O. This means that we don't need to block the main thread. We can schedule. We can make all of them access our resources from our machines or databases and so on asynchronously. So I can keep receiving requests. I can schedule a bunch of tasks, but using the same amount of memory. So when you start up your Node.js project, you have a pre-allocated memory that we use for most of the requests. Now, the same example we saw on the previous execution module. We receive a request, but Node.js, instead of scheduling any resources, it has a queue. So for each user I have, I'm going to just in-queue them there so I can support thousands of users. I won't spend too much memory on this. And well, when I have too much that I can support, they can start receiving set timeouts. They can start receiving timeout errors, right? But still, we can get all those users. We can in-queue all those requests right there. And one interesting thing, when we have those loops, when some customer just finish, we are able to receive even more and more customers on there. So the event loop, this loop of requests, or this loop of what we are processing, it's where is the magic behind the Node.js. So the main point here, I would say the best thing about this execution model is we don't need to reserve more memory, right? We can use small servers, even Raspberry Pi, to support most of the applications. I would say most because huge applications, we know we need even more resources, memory, and events to handle. Well, so the key points there were non-blocking async I/O. So we can handle a large number of users trying to read files, access databases, and Node.js was scheduling tasks and events behind the scenes. So in contrast to the other execution module, we don't have any bottleneck. All the main thread is free to receive requests and is scheduled to the operating system. But then we just keep receiving, and we have no problem. And Node.js uses a very lightweight process for handling those users. This is what we call the event loop, right? So the event loop, instead of threads, we have a bunch of events. We are just running those events, scheduling, and try to synchronize those data. And it enforces asynchronous programming, right? So using asynchronous programming, it's more efficient because we don't have to wait anything. We are just scheduling. So all this module is asynchronous in the end, and we can process many parallel requests at the same time. And it was built focused on real-time applications. And because we have the event loop, everything is executed in order. So we won't have to handle the threading, right? The thread lock that we saw in other programming languages. Here, they are just executing in all lines. And this is a common mistake. I remember I got into a fight on LinkedIn because some people from Apple, they say, no, JavaScript is not multi-threaded. And you're going to see today that JavaScript isn't either multi or single-threaded. JavaScript is just the programming language we use to interpret and to convert to C++ instances. But this is another subject. Well, Node.js has always been multi-threaded. If you take a look like, oh my God, most of people just say, don't use Node.js because it's not multi-threaded. You cannot reach what you are reaching in the other programming languages. But if you look at the docs, there are a bunch of texts, right? Let's just get some idea from there. So Node.js uses the work pool to handle expensive tasks. So when you spin up your Node.js process, you have at least 4 threads since the version 1 of the Node.js. And they use for I/O intensive, well, when you have to read some DNS or when you have to use crypto, some CPU-intensive tasks, Node.js is just scheduling to those threads. But see, those threads, they are always there. There are at least 4 threads. When Node.js needs to run some heavy tasks, it's just scheduling to those pool of workers or threads and executing them all. Well, one thing that why people think that Node.js is not using threads, it's because we hadn't had any API to use threads, right? But recently, I would say 2 years or 3 years ago, we have this public API now in the core, so we can use worker threads, okay? Now you can schedule other operations, but in the end, it's very edge cases when you need threading Node.js. The cool thing is that you're not using threads for everything. And the event loop is single-threaded, okay? And this is what makes Node.js special. Because we are not using threading, we don't need to schedule more memory. We don't have to pre-allocate more and more according to another users going to our server. And this is very nice. And as I told you, you don't have to synchronize. You don't have to handle semaphores of threads and much more. All right, this is time for magic, right? Well, now we're going to go to the hands-on party, okay? Everything I did here is already on a Git pod. So something that I struggled a lot to make this work was trying to build the Node.js, all the components, right? So I remember I spent, from the month I spent for the whole project, I would say 3 weeks was only trying to build all the libraries because I'm not a C++ developer, okay? So as I told you, the first thing I did was going for the Node.js repo and try understanding what Ryan Dahl was doing in the v001, the first ever version that we have in the GitHub. And see, I don't know if you can hear, if you can read from the back, but the first commit, first compile, intermediate commit, nothing works. 3 dots. I don't know about you, but for me, they were like genius, right? All people working at Node.js, creating Java, creating C++. I was like, those people, they have a huge brain, right? They know a lot of stuff. But in the end, they are struggling like us, right? Like normal people working at our projects. And if you go there, you're going to see a bunch of there, like add web page, very incomplete. Trying to implement stream upload, not working. I'm not sure about you, but I don't usually commit those mistakes, right? I don't usually try pushing to GitHub when it's nothing working. But see, Node.js wasn't something planned, right? Ryan Dahl just did an experimental thing. Ryan Dahl was trying just to use what Google was using there and try understanding what could be done. But then it just got to the hype and people start using. And see, here, this first V1 came in 2014. The 001 was in 2009. So we see a gap of at least 5 years, right? Well, if you research about the Node.js story, there were a bunch of fights in the community, and we had any other forks, and it was very messy. But then they came up with some solution, and they released the first version. And back then, it was called IO.js, right? Because of the whole thing, it was about Joint, and it's pretty interesting to see how Node.js is evolving since then. Just to summarize all the threads here, what they did was to create a Node.js foundation. So now there were a group of people that could say what should have on the Node.js instead of just a single company owning everything. Well, as I told you, this project is already on GitHub, right? I'm going to show you the step-by-step there. And I call this project Capybara, right? It's a very popular animal in South America, in Brazil mostly, and I just got this name. I was telling you, the hardest part was the compilation of this thing. V8 is the engine, right? It's what is executing JavaScript, what is parsing JavaScript to C++ instances. So there you can go, and there are some tutorials, but they just don't work. I don't know what happened there, but it's pretty hard to understand. So this took me a while. But if you want to understand how the complexity was on this thing, first you have to download from the repo. When I downloaded, it was, I would say, gigabytes of a huge repo. So I had to download it, and then I had to set up my architecture. My God, this was crazy, crazy. So I have to understand what is the architecture. I have to change like XML files. My God, it was hard, my God. And start compiling. So I press compile, I go, get some coffee, and then I see error. So I was the complete week or 4 weeks just seeing a bunch of errors, but finally it worked. Well, we're going to wait a bit, and then we're going to run the tests. So this is how we know if Node.js is working fine, if V8, only this small part is working. And then we can move the binary, we can get all the headers and copy and paste to the application. I know, it's advanced content, right? I know you're probably seeing like, no, I should see the code to remove just this abstraction in my mind and see how it's working. Well, as I told you, everything here is on Gitpod. It was amazingly fast to create tutorials from there. I put all binaries there so you can just take care of your code and so on. And everything is already there. You can see the binaries are there too, and you can start working. So you're going to see all the prints are from this environment, so it's going to be easier to make it. OK, let's understand the main components and why I try to use the same components, right? We have JavaScript. We have V8 that I just told you that is the engine. We have C++. So Node.js is written in C++, but there are Rust versions for other runtimes as well. And we have Libuv, OK? Libuv is this pretty, I'm not sure it's a unicorn on a dinosaur. I don't know, you tell me. But this is the library for asynchronous operations. So every time you want to read a file, if you try reading from C++ or from the native C++ API, it's going to be blocking, right? Once someone is there with the file open, nobody can access it. So Libuv made this way easier to handle those operations and make them be accessible in parallel. And inside Libuv, you have the event loop. Remember, just the while true, the loop I was showing them. But let's get to the diagram, because I think it's easier to understand. So V8 is grammar, OK? V8 is promises are set, maps, const, classes, promises, all data types that we have there, OK? So any function that we use for JavaScript, for the grammar, are on V8. And we have the Libuv working there. But let's just think now that Libuv is just a while true loop. It's just a while true asking for events. Is there any event pending? Just patch all pending events and then start doing again. But here is the magic. Here was, for me, the layer that just blew my mind. Here we can extend V8, we can add new behavior, and we can try getting data back and forth from JavaScript to C++. Well, in this experiment, I will have a print function, OK? Print doesn't exist in JavaScript, OK? So when I compile V8, we're going to see the whole context, the whole global, is empty. This means that process doesn't exist, and all globals, they're not there, OK? Related to Node.js. But see, how can we implement print? First, in the Node.js, in the C++ side, we're going to define print. We're going to use global set to extend V8 and see. Every time I have this keyword print, you know that I'm telling about the C++ function. And now you're going to see that global this has this new function. And there on the V8 side, we're going to see that we have print, right? So it's now extendable, OK? We can inject new functions. And this is why Chrome has a different API, right? Chrome has the DOM API, and Node.js has the operating system, the file system APIs. But they are all doing the same thing. They are just extending so you can call those functions from JavaScript. OK, let's make it harder. What about a set timeout? The same idea. I define in C++, I extend the V8, and now it's both on my global disk and on the V8 side. So it's pretty straightforward. Notice here that I'm using UV timer start, OK? I just put it there so you can know that I'm using libuv. Anything that goes to the environment, anything that is not related to my code, anything that I'm reading a file, requesting an API, they are asynchronous. They are not on V8, OK? The only thing that is natively on V8 is actually the grammar and the JavaScript, OK? So my first mind blow was like, oh, wait. Node.js is just extending, right? I would say just, but it's very clever, right? But in the end, there's no such a thing of magic. I was like, there is JavaScript there, but there's C++. But in the end, they are just extending the behavior. So let's see now the code finally, right? Are you with me? Oh, so yeah, let's see this in practice. So here I have a print file, just a JavaScript file. And then I'm going to go to the main program here just to show you how it's done. So as I was showing you, first we have to read a file, OK? So remember, index.js, server.js, remember that we use Node, and then we use a file name, right? We are just passing the file name to Node.js so we can read the context. We can read all the strings from there, and JavaScript is just a string. This is crazy for me. It was like, oh my god, this is not magic, right? And then we use the compile. Remember I told you, we receive JavaScript, we use compile. So compile, you transform all those JavaScript calls into C++ calls. And then we can execute it. We can use run. When I'm using run, it's exactly the same thing of using eval in JavaScript. Exactly the same thing. I'm just passing and executing so I can get the result, and I can wait for events. But I'm going to show you the events right soon. This wait for events is where the while true is happening, right? So see, I didn't need to do anything here. I just called the UV run, and it's pretty straightforward. This is why I think this became so popular for Node.js developers. OK, let's make some magic here. When I'm working with V8, as I told you, I had to compile everything, and there was no such a thing of tutorials or docs on the internet. And even the developers working at V8, they didn't know how to help me. So I had to struggle a bit. But see, I have a make file, and the only thing this thing is doing is linking all dependencies, OK? Just make sure it's only thing. So as I told you, once you compile the V8, we're going to have this file, the monolith, and I have to put all the C++ headers. These C++ headers, they are just references on how you can call operations from those binaries. It's pretty nice. And then, as I told you, I'm not a C++ developer, right? But I'm a Node.js developer. So in Node.js, to watch files and to see, like, restart all my server, I use nodemon. So I try using the same thing and execute my C++ or my C++ building. But let's see this in practice. So here, I'm using make, OK? Make is going to generate for me the binary, which is capybara, as Node.js is doing. So I can execute this binary and just call my index.js, OK? And print is there because we already created on the diagram, OK? I just put it there, but you can execute and see the result. So when I got this first result, I was like, oh my god, it finally worked. But it was just a hello world, right? This just the first excitement. But I wanted to do set timeout and all other operations as well. Well, I would say if you don't remember anything from this talk after, you're going to remember this. Set timeout, set interval, and console.log are not JavaScript. For me, it was like, my god, I was calling my mom and saying, Mom, console.log are not JavaScript. This is crazy. Because I remember using console.log since the day one, right? And they're not JavaScript. This, for me, was mind-blowing. So what happens if you try calling this function from there? I would say, if they don't exist there, I would probably see the undefined is not a function, right? So I try running there, and you see, there's no error. But if I try printing the console object, there's object. And if I try using console keys, they are there. Now you can ask why. I don't have an answer. I think probably they just implemented an interface to make it faster because every runtime is using this, but no idea why. OK, so what if you try using setTimeout? setTimeout is not defined. What about interval? Not defined, OK? So we just proved that they are not JavaScript. Why? Because we are using only V8. If you are using V8, we are using only the JavaScript side. There is no magic until here. But this is not just mess, OK? We have working groups that show how runtimes and how other browsers can implement console.log. But you're going to see they're only like signatures. They don't say how the operating system or how the environment should return the data for you. So you can use probably on Ruby puts, and you can use in C++ the printf, and they are all console.logs. OK, let's dive into this code a bit more. So if you take a look at the print, I was telling you, printf was my first, I would say, the first command I've used in my whole life. I started like on the university using C++ to learn programming, and printf was the first instruction. And here, Node.js is using print since nowadays. It's crazy, isn't it? It's amazing. So when I have this function, print, I have to extend the global state, right? As I showed you there. You just use the global set. We pass exactly the same string there, and now V8 understands how you can call from JavaScript. And then, after it, we can start playing with JavaScript, OK? So we can use date. Date is a very weird object, because it relates to the environment, but it's not JavaScript, right? It's not just, it's an exception for everything. And here, we can see we can use complex objects. We can use map. We can use spread parameters. And we can use promises. Promises are not asynchronous objects. They are just wrappers for callbacks. So this was, for me, crazy also, because I've been using promises a while, and I thought they were asynchronous functions. But they are not. They are just helpers for us to create with them. But yeah, V8 has everything. So with this project, I was able to execute my own projects. I was able to execute web APIs and a lot of other stuff because I can just reuse what JavaScript does. OK, when I reached this point, I said, OK, I know the JavaScript side is working. I know console.log is working. But I wanted to use Libuv, right? I wanted to see how the loop was working. So I was like, let's try doing this. So first, we need a function, OK? So don't pay too much attention on the C++ side, OK? Let's understand here that we are just grabbing the parameters, OK, for sleep interval, and I'm grabbing the callback right there. So this was already parsed when we use compile. And then I have to have a way to store this data. Remember, when I'm using setTimeout, I say that a function is going to be executed in the future. So when they're executed in the future, I want to have the whole context, right? I need to know what variables and whatever I can use there. So I store this in some object, and then I can call UV_timer_start. UV_timer_start will just say, I'm going to use this timer, and I'm going to call a callback function, which is another C++ function for that. So we can go there and see, when this timeout is over, we're going to parse it to a callback and call my JavaScript function from C++. This is what I told you. JavaScript is nothing, right? JavaScript is just a string being interpreted in the end. So we are just executing C++ code and parsing objects back and forth. All right, I'm going to do the same thing. I'm going to extend V8 and set the setTimeout function there so I can be able to execute it from JavaScript side. And then here, I'm going to call it from JavaScript side. But see, because setTimeout, because the timeout I created there receives a callback, I can use promises, and I can use async await. Async await are JavaScript, so they are on V8. So for me, it was like, ooh, this is getting interesting, right? If you try executing this code, was for me the most magic moment. I would say one of the most magic moments of my whole career, right? I saw, oh my God, it's working, it's respecting all the time, and finally it worked well. So for me, it was a huge accomplishment because it was pretty hard to make it. And if you go to the Node.js v00011, you're going to see Ryan Dahl, he did something similar. He was just exposing the timer, which is the C++ their function, putting on the context, and he can create new functions. This is how Node.js today, we have a bunch of code in JavaScript and a bunch of code in C++. What they do, they are exposing some APIs from C++, so we can handle from here, from JavaScript, which we know, right? When you go to the repository, we would have like thousands or hundreds of contributors working on JavaScript side, but the C++ side, it's hard, right? Because we need to learn a new language. So most of them are trying to expose the main APIs so we can call from there. And remember, V8, when we are working with V8, V8 is just the ECMAScript specs. So everything that is on the ECMAScript side, we're going to see there. But any other functions, any other operations, they are extensions. And now we can see how big Node.js is, right? Because we have a bunch of native modules, and it's pretty fast, even though they are being extended or they are being executed on the startup time. OK. Now, I would say this was my main motivation to start creating this. I was like, why now we have Bun, we have Deno, we have Cloudflare workers, and a bunch of other JavaScript runtimes appearing? Is it easy to create a JavaScript runtime? Why they are there? Well, I was browsing the files, and I went to Deno first. So Deno is Node.js backwards, right? Just a great competitor also. But if you go there, you're going to see they are doing exactly the same thing we're doing in C++. They are reading the whole script you have. They are just grabbing the file there, parsing to Rust functions, and executing exactly the same thing we did in JavaScript, in the Node.js, right? OK. They are injecting also a bunch of stuff. I'm just showing you just a matter of curiosity, OK? But I was at the Deno repository also. And Deno was like, is it the same thing? Like, Bun was using Zig was using a JavaScript core, which is another interpreter for JavaScript. But still, if you go there, they are just extending functions. They are just handling behaviors and doing a lot of stuff. So yeah, now probably you're going to be thinking, OK, what makes one JavaScript runtime better than others? Why Node.js is from like 2009, and now we have a lot of others appearing? Well, if you go there at the Node.js core, this is the code for the FS, the file system module, and we see a bunch of exported functions so we can call from JavaScript and execute them. But see, what makes one runtime better than other, it's how they are handling the responses from the operating system, how they are responding JavaScript back and forth. If you go to Bun, you're going to see that Bun says that it's faster because the algorithms, data structures he's using behind the scenes to make everything work. So here it's pretty interesting to see how those environments and how it's great to see Node.js evolving and all those libraries also. And my opinion, developer experience, right? Deno had a lot of test runners. They have TypeScript. Node.js is using JavaScript, and a bunch of different stuff. And most of the developers, I wouldn't say most, but a lot of developers liked this because of the developer experience. But there are no competitors. People are saying, oh, no, we should use one, we should use another. But see, Jared Summer is the creator of Bun. And Colin Rigg, he's part of the Node.js since the beginning. He joined the Deno organization. And see, I would say this sprint was 2023, and we had a test runner, right? So something that we always wanted in Node.js, but now because of those competitors we are implementing and improving Node.js. especially in the performance side. Great, isn't it? I see a lot of faces like, oh my God, it's a bunch of things. Well, all those runtimes, they are trying to collaborate together to find some standard, right? I showed you, we had console.log, but if you create your own runtime, you can call whatever you want. You can call print. So I think in the future, we won't see what is the runtime behind. We're going to have the same API for everyone, and AWS, Google, or other cloud runtimes, they're going to choose whatever they want, right? Whatever fits most for their own infrastructure. OK, we are almost there, OK? As I told you, I know it's a bunch of information. I know it's hard to digest. So go to the tutorial, do the step-by-step. And I'm not telling you just it's a matter of curiosity. When you understand those three main components, you know better where to find a problem. So we have a memory leak. Memory leak is the V8 side or is the Libuv side. Probably we are scheduling events, the Libuv side, OK? So we start wondering and we start thinking more about what we are using behind the scenes, and it makes way better to understand and to discuss in a high level with your team. Very nice. OK. So if you want to follow more content, I've been creating a bunch of stuff on my website. You can go there, follow the talks, follow more content. And this whole content, I made an ebook. So you can go try the step-by-step, an ebook as well. And there, I created a very cool challenge for you. So you're going to recreate the Node.js read file function. So you're really understanding how this is behind the scenes. All right, everyone is with me yet? People's like, oh, a bunch of content, right? It's nice. Well, before I finish this talk, I have a tradition to make like a to make people envy, right? They are not here, they didn't come. A bunch of friends say they come. So I'm going to count out 3, and we're going to make some noise, OK? OK, are you alive? Nice. So on 3, we're going to just put the hands on the air and make some noise, OK? So, oops. So 1, 2, 3. Hey! Thank you so much, JNation.